All right, well, thanks everyone for joining today. What we'd like to do is overview our upcoming release of the new Angus genetic evaluation that will take place on July the 7th, and overview some of the changes that breeders are expected to see. So on July the 7th, we're releasing a new set of EPDs. It's based on new methodology called single step, but it also implements some new models, and we're basically calling it a new evaluation. And we've been running this single step evaluation since November, and at that time we noticed the results are different, and we were basically focusing then on, are those different results actually better? And we've done some testing now to realize that they are better, and so we're confident to release them to breeders and excited to do so. And this quote here, that different isn't always better, but better is always different. You know, we couldn't give breeders something better that wasn't different. So what we're going to do today is not focus so much on methodologies as much as focusing on changes that breeders can expect to see, and where are these changes coming from. I use this analogy kind of as a high-level description of the difference between what we do today versus what the methodology is for single step that will be implemented here on July the 7th. And that is, with grain harvesting, you know, it used to be a two-step process. You used to go to the field with your binder and reap the grain into sheaves, and then you'd take those sheaves to some stationary threshing machine, feed them through the threshing machine, which would sort your grain from your chaff and straw. And then somebody ingeniously said, you know what, why don't we combine these two processes in one unit here that would actually reap the grain and thrash it all in one pass. And that probably came about because you had larger, more powerful internal combustion engines, but that's the origins of the combine. It combines the process here of creating the sheaves and reaping the grain as well as thrashing it. And really what we have been doing is a two-step process with our genetic evaluation. We've been taking our genotypes and running them through an equation to calculate an MBV, and then we took that MBV over to our genetic evaluation and we fed them in as a correlated trait. Whereas now we have a machinery where basically we feed the genotypes and the pedigree and the performance information all into this fancy new combine, which is our single-step genetic evaluation, and out the other end comes our genomically enhanced EPD. So it's more productive here and internally, which breeders should appreciate as well, because going forward it's actually going to enable us to do more and better models for our genetic evaluations. So what we do today is actually based on some methodology that came about from Steve Kachman from the University of Nebraska in 2008. He presented at a workshop here in Kansas City with the Beef Improvement Federation. And at that time, molecular breeding values were kind of new on the scene for breeders. And the question for breed associations and those doing genetic evaluations was, how are you going to get that information incorporated into your genetic evaluation? And actually, it's a really nice approach that Dr. Kachman suggested, because it didn't require us to change too much our genetic evaluation methodology. You know, we were already doing genetic evaluations, we were already doing multi-trait genetic evaluations, and now we just fit another trait, which is the actual MBV, or molecular breeding value. So what that looks like in this correlated trait model is, here's an example with carcass weight. On the diagonal here, carcass weight has a heritability of 38%, and we're going to fit carcass weight, but we're also going to fit a 50K prediction for carcass weight. And it has a correlation with carcass weight, depending on how good the prediction is. But in our case, that MBV is correlated about 0.7 with actual carcass weight. And the MBV itself has a high heritability. And so this is basically what our correlated trait two-step model looks like that breeders have been seeing since about 2010. And so that was a really nice model. It served us well. But the problem is it's not that simple, because in practice we don't just evaluate carcass weight. We evaluate carcass weight along with a bunch of other traits. And each of those traits just doesn't have a 50K prediction, but we also have some historic predictions in the system. So along the top here we've got carcass weight, but we run carcass weight with ribeye area because those two are correlated. They're both kind of size traits. And then we want to also correlate that with live weight traits that the animal might have. In this case, it's scan weight. And because ribeye is correlated with the ultrasound traits for ribeye, we've got ultrasound for ribeye in bulls and females and steers. But we've also got these genomic predictions for carcass weight and rib. And there's 6 of those. So we have to fit correlations between all of these molecular breeding values and all the traits that we evaluate. And basically all these red X's here are all things that we're fitting in our model that are just due to the molecular breeding values. You know, it's not something that the breeders actually gets reported back to the breeders. The breeders see, you know, ribeye area, carcass weight, come back to them. And what we found, or as these things have gotten more complicated and the data sets have gotten bigger, that all these off diagonals to fit is basically what I call a bear. So with single step, it's actually a lot more simpler and it's more direct. Now we just evaluate the traits that we're interested in. And the genomic information basically influences the pedigree. So we're modifying the pedigree and the relationship among animals based on the genomic information, but the actual traits we're evaluating now are just the traits that actually get measured on the animals, which is great because it's much simpler. But that's actually opened up a new opportunity for us, and that is to add some traits to this model. You know, back when we were running this model, the thought of starting to add more traits makes the thing even bigger and more awkward. But when it's this simple, the opportunity to add traits is there. And that's essentially what we've done with the carcass model. So I know on 7.7 there's going to be a lot of talk about single step, but actually in terms of carcass, there's been big changes. And that is we've changed the carcass model quite a bit. It's a lot better than what it was, and the reason we were able to do that is because single step is simpler and it just streamlines things for us and allows us to do that. So some important improvements are we've actually added some traits to our carcass weight model. So in the past we had scan weight, but now we've actually added weaning weight. And the important thing about adding weaning weight is, you know, the animals that go on to get scanned are not a random sample of those that had weaning weights. Yeah, typically if you're growing out bulls, for example, you know, you take all your weaning weights that come weaning time, but only the heavier bulls typically would go on to have scan weights. So they are genetically typically superior for growth rate. And when you fit weaning weight and scan weight at the same time, you account for that pre-selection. And that's really important. We do that now with our growth models. That's why we run weaning weight and yearling weight together in the same model. And now we're going to account for that same pre-selection bias in our carcass model. The other thing we've done is we've added fat traits. So the ultrasound fat traits as well as carcass fat has been added. And this is helping us pick up differences in maturity pattern that could influence carcass weight. Basically, animals that are fatter at a year of age tend to have slightly lighter carcasses. They're earlier maturing and they'll have slightly lighter carcasses than animals that are basically leaner at a year of age. And this is different than the relationship between carcass fat and carcass weight, because fat is part of the carcass. It contributes to carcass weight. You know, fatter, if you run animals, if you make them fatter, typically their carcasses are heavier slightly. So those correlations are not real strong, but we have what we're doing with this new model is we're taking account of that difference in maturity pattern, which is influencing the EPDs now. And what breeders are going to see right away is there's a stronger relationship now between the growth traits and carcass weight. And carcass weight it's a revenue driver in the dollar indexes, dollar B especially. So there's a stronger relationship now between say yearling weight and carcass weight, especially for young animals that don't have any data yet in terms of carcass records. So back in November, we were looking at our two systems side by side, running side by side, and they're different. Are they better? And it wasn't until about February, visiting with Larry Keene at the USDA, that we realized, he at the USDA Meat Animal Research Center in Clay Center, Nebraska, They've been evaluating Angus sires for a number of years, and they have an independent data set to what's here at Angus across almost 200 sires. And within USDA mark, they can calculate EPDs based on their data. And so we compared how do the EPDs that we calculate with multi-step and single-step, how do they correlate with the USDA mark data. And what we find here for single-step, if you look here, for example, birth weight's slightly better, carcass weight slightly better, fat's a lot better, milk's about the same, marbling is quite a bit better, ribeye's better, weaning's the same, and yearling weight's slightly better. So in all cases, it's either the same, and that's a good story as well, because it's saying, well, it's the same because you're multi-step, we had a lot of data, and the method we're using wasn't wrong. So the numbers we were producing were good predictions as well, but just the ones with single step are just a bit better and have a bit better correlation across those traits. The other thing we did was we looked at, well, how does single step and multi-step, how do they predict actual Angus data that's coming here? So we did a validation where we basically cut off the data at the time of the last calibration for multi-step, and we said, okay, let's forward predict now animals that have been born since then and look at their weaning weights and yearling weights and birth weights and see, okay, the single step prediction, how does it relate to the weights that come in on those animals versus multi-step. And in each case, these bars, as this number goes up, basically there's a better relationship between the EPDs that we predict on animals and their actual phenotypes. So it's important to realize that those animals' phenotypes did not get included in the evaluation that contributed to this, say, single-step prediction here for yearling gain. So, it's kind of an independent set of data. We purposely carved up the data that way to allow that independence. But basically, single-step here has a better relationship with the phenotypes than multi-step for yearling gain, weaning weight, and birth weight. So again, we've got kind of growth in carcass traits coming out of USDA mark, plus our own data tells the same story that our single-step numbers are doing a better job. Something else that we can do with single-step is we can pull out a kind of a genomic-only prediction, and now breeders see genomic percentile ranks, and they're still going to see those, but they won't be based on that equation that is an MBV anymore. They're going to be based on what we call a direct genomic value, which is basically the genomic-only value that comes from single-step. Another thing breeders will see is basically accuracies with genotyping are higher now than what they have been. So here's a little example for weaning weight, and what we see here, animals that have no phenotype and no genotype have no accuracy, and that's the same for multi-step and single-step, so that makes sense. Now this 0.02 accuracy is actually what gets calculated behind the scenes. We don't present accuracies less than 0.05, so breeders wouldn't see that on their reports, but that's just behind the scenes. Those accuracies are the same. For animals that aren't genotyped, the value of just a phenotype, the accuracy is pretty similar. It doesn't go up very much. A little bit because their heritabilities have changed, and that's something else that's important to realize. Not only have we implemented single step, but we've actually re-estimated all our heritabilities, and they're published on the web, so breeders will be able to look at those. In most cases, they haven't changed very much, but again, just a little more accurate and kind of fine-tuning. That's something with a genetic evaluation that you might undertake every 5 to 10 years anyways. But where we see the differences here is when we get into these genotyped animals. So, here's animals that have no phenotype but a genotype. Before we were publishing accuracies at 0.28, and now they're jumping to 0.42. So if you think before, here's an animal with a phenotype and no genotype, they average 0.25, and we used to jump them to 0.28. That's not a big increase, but now we're jumping them from 0.28 to 0.42. So that's a bigger increase. But there's a lot more data behind our evaluations now. The previous calibration was based on about 100,000 animals with genotypes, 108,000 I think, and now we have over 300,000 animals genotyped in the population. So we've kind of tripled the size of the training set, you could say. So we do see it. We're seeing a jump in the accuracies. Something else we've always kind of presented and showed to breeders is kind of this progeny equivalent table. Basically, if you have an animal with a genotype, what kind of accuracy do you get, and then how many progeny would it take to get that same level of accuracy? And so what we see here for some we see some changes. You know, we've got a lot more accuracy now for milk in terms of progeny equivalents. Our genomic predictions for milk seem to be better than what they've been. Again, we've got a lot more data. Milk's a difficult trait for beef cattle. Plus, the heritability for milk is a little lower than what we did have in the evaluation. So it's 12% now, and that helps to increase that number a little bit as well. But we've often kind of used a rule of thumb of around 10, and that number is not too much different for some of our carcass traits. So 8, 9 progeny for dry matter intake, carcass weight, marbling, and the carcass traits like ribeye area and fat. Pretty similar to what we've been seeing before. And when you think about it, that's a lot of value. You know, what's it going to cost to actually phenotype 8 progeny on a bull for a trait like dry matter intake or even carcass? To be able to get that with a genomic sample is really valuable. So something that's going to contribute to differences that breeders see is differences basically in our genetic trends. So what we see is what's on this graph here is actually a genetic trend line for marbling, and this is a genetic trend in green for what we call a classic genetic evaluation. So with a classic evaluation would be a genetic evaluation where we've analyzed the trait, but we didn't fit genomics at all. So this is kind of like pre-2010, how we analyzed data when we didn't have genomics. And that's our genetic trend from a run like that. Now, under that line, which you can't see very well, is a blue line, which is actually our single-step trend. And what we find is our single-step trends and our classic trends are almost identical for all traits. And we see different trends with multi-step, but as we've done some analysis, we realize our single-step trends are actually more accurate and a more representation of what's happening in the population. So the differences in trends are going to change, kind of the differences in the mean EPDs for animals born in different years and where animals rank in the population. So what the message we'd like to get across to breeders is, you know, on 7.7 it's a new evaluation, and with a new evaluation that there's different properties like our genetic trends and like our percentile tables. So, you know, what is average now in the population? What is the top of the breed? What's the bottom of the breed? That's going to change, and it's different for all the traits. So people are really going to want to focus on what those percentile tables are and basically kind of readjust their sights and readjust what they know as in terms of what's high and what's low for our different traits. So just digging now into what our different trends look like, and in all these graphs that we're going to go through here, the yellow line is what's going to come out on 7.7, which is our single-step new evaluation trends, and the blue line is what is today. If you took the values that are on the website in Excel and plotted them, you'd get a trend line just like that. So the implications of that is what we've done is we've across the board implemented our EPDs such that animals born in around 2010 average the same for what gets published today versus what will get published on July the 7th. And we did that so that recent animals, you know, the scale of their EPDs isn't going to change that much. You know, what do you think is high or low for the different traits for recent animals won't change. But because the trend is different, that influences these older animals. And I'm focusing now on 1990. But in 1990, because this trend is flatter for single step, we actually see about a half-pound reduction in EPD on average for animals born in 1990. That's what's going to get published on 7.7. Interesting with birth weight, and birth weight's a trait that I'd say is probably one of the most looked at traits and important traits for breeders. based on calls that come in. But we have a flatter trend for birth weight now, and what that means is over time our multi-step trend for birth weight was going down. So over, the animals are getting lighter at birth, and it's still going down, but it's not going down as fast. So we're not going to see that same downward trend as rapid for birth weight. And that's caused by something else that's been implemented that's coming up, and it's not going to be available here on July 7th, but probably in August, and that is the association will start to take birth weight records without weaning weight records, and that's something unique to Angus. But now we actually have a genetic evaluation that's fitting a correlation between birth weight and growth rate, and as we know, the trend for growth in Angus has been going up. And so with a trend upwards for growth, and when you have a positive correlation between birth and growth, it brings up the trend for birth weight. And that's going to be most important for bulls that don't have all the data. So if you can imagine someone, for example, that didn't collect birth weights, they submitted all their yearling weights, and here's an animal that's kind of top of that group for yearling weight, the most heavy animal. Without a birth weight, the system's going to say, well, you're big, and we know that's correlated with birth weight, so your birth weight EPD is going to come up a little bit. Our yearling EPD is actually a little bit steeper, and so when we fit, the 2010 animals are about the same, and in recent years we don't see a big difference. But if we go back in time with that steeper trend, these older animals, their average EPD is going to come down. And if we look at 1990, for example, that equates to about a 10-pound reduction in average EPD in 1990. Milk, on the other hand, is flatter. And this is partially a function of a slightly lower heritability for milk. And I know breeders are another trait that they're keenly interested in. And what we'll see now, although in recent years it's the same, we're not going to see milk going up on bulls as fast as what it has done. It's still going up, but it's not as steep as what it has been. And the implications of that is these older animals, their milk EPD is actually going to go up slightly. So 4 pounds would be the number in 1990 that we'd see on average animals are going to increase for their actual milk EPD that gets published. So focal points for July the 7th. We really want people to focus on those percentile tables. Because again, if we go back to those trend graphs, on average, animals born in 1990 are going to go down 10 pounds, say, for yearling weight EPD. But that doesn't change where they rank in the population. So that's important that the actual number is it's on the same scale as it has been. It's still in pounds of yearling weight, but we really need to compare animals to animals on 7-7 to realize how animals are different. Comparing back to the previous evaluation is really an unfair comparison because you're comparing animals across two totally different evaluations. In the past we went through these calibrations and people are used to that, but this is more than a calibration now. This is not just we've added some more genotypes. We've added a lot more genotypes. We've changed the method, and we've changed the models in some cases, and we've changed the heritability. So it really is a new evaluation. People need to look at those percentile tables and kind of readjust what they think is high and low for the breed. Just the point that here, the change in EPD is not equivalent to a change in rank in the population from June 30th to July the 7th. And just to give an example here, I picked out dry matter intake. The old 50th percentile was 0.18 and the new one is 0.27. So, if your bull was 0.18 on June 30th and you wake up July 7th and you look at his evaluation and it says 0.27, that looks like a change, but actually he's still the 50th percentile for the breed. So there really is no change. Those two numbers now are essentially equal. So just moving into the carcass traits, and I think this is one that people have the most questions about. My carcass weight EPD's changed. Why? And it'll largely be due to the fact, not so much single step, but due to the fact that we've actually changed this model. We've added in weaning weight as a correlated trait and fat as well. It's a better model. And what we see actually with just the way it worked out, the carcass weight trend is actually really similar. So accounting for the pre-selection and everything has actually made our multi-step and single-step trends pretty similar in recent years. So how did these changing trends actually affect the EPDs? Now, we're not going to walk through all the traits here, but just as a pattern, you know, in 2010 they're going to be about the same. They intersect in 2010, but if with the new evaluation here in orange, you know, if it's steeper, that means all these animals back here are going to be less than what they were. And if it's flatter and we intersect 2010, then all these animals back in these years are going to be higher than what they were. So the average EPD with a steeper trend, average EPD comes down. With a flatter trend, the average EPD goes up. And across the traits, the pattern would be we're going to see EPDs on average, especially for older animals, go down for calving ease, birth weight, weaning weight, yearling weight, dry matter intake, mature weight and height, increasing for all these traits. And one trait that doesn't change very much is docility. So focusing in now on how we can see animals change, you know, how are individual animals' EPDs going to change. You know, I made a presentation at BIF a few weeks back, and that was one of the big questions at the end was breeders, or the question from the floor was, are bulls going to change rank? And the answer is yes. You know, there's going to be relatively big changes for some animals. And just to give you a magnitude, we have what we call our top 200 sires, which are the sires that basically registered the most progeny recently. And what I've done here is I've randomly picked 100 of those, and I've put them on this graph. And each of these dots is one of those bulls. And on this scale down here is basically what his EPD is published today. And on the vertical axis is what his EPD will be published on 7/7 or close to it, because that run hasn't happened yet. But based on last week's run, this is what his EPD would be. So, you know, here's a bull that was just shy of 20, and he's going to be just shy of 20 on 7/7. So he really doesn't change very much. The pattern is such that, you know, the high animals are still the high animals. These animals are 15s and 20s, and, you know, these animals are zeros and negatives, and that's still the same. Here's an animal that was minus 20 on the old EPD. He's going to be about a minus 6. So he's still negative, just not as extreme. If we get into the middle here, we see where we see more movement. And for example, here's a bull that was 5. This dot here would be a bull that was 5, but his EPD coming out on 7/7 is going to be basically 10. So that's an example of a bull that went up. Here's a bull that was 10, and he's going to be 5. And so that's, you know, for breeders, a swap from 5 to 10, either way is a big change on bulls. So those are big changes for calving ease. The overall correlation here is 0.91. So it's still highly correlated. That's why we don't get a scatter, but we get a nice upward trend here. Birth weight, the correlation's higher. It's not 0.91. It's actually greater than 0.99. And I put greater than because actually when it rounds, it's actually almost 1. So we see very little wiggle here in terms of what bulls were versus what they're going to be. You know, bulls at 2 are still at 2. Bulls at 3 are still at 3, etc. So we don't really see too much movement on the growth traits like birth weight. Yearling weight, similar story. You know, bulls out here at 150 are still 150, and bulls down here at 70 are still 70, and very little change there. Milk, we do see more movement. Again, milk is a trait, difficult trait in beef cattle. We've got a lot more data with milk now behind our genomic predictions. Correlation's 0.81, and so if we look here, you know, again, the high bulls are still the high bulls and the low bulls are still the low bulls. But here's a bull at 40. He was 40. He's going to go to, this bull here was 40. He's going to go to 25. You know, another one that was 40 is going to go to, what's that, about 38. At the other end, you know, here's an animal that was 20. He's going to go to 15. So that's not a big change. An animal that was 30 is going to go to 20. So just to give you an idea of the types of movement that we can see. Marbling, similar story to calving ease that we saw earlier in terms of a correlation here at 0.9. Here's an animal that was 1 on marbling. It's going to go to 0.5. That's a big change for a bull. Here's an animal that was, 0.5, and he's going to go just slightly bigger than 0.5. So again, animals that were up pushing 2 on marbling are still pushing 2 on marbling in terms of an extreme value. But again, it's not a scatter graph. It's a nice trend, but we do see movement here that people would consider significant on bulls. Similar story with ribeye as to what we saw with marbling. Slightly more change, and that's because we haven't changed the marbling model, but we have changed the ribeye model, and it's to do with that correlation with carcass weight and pre-selection that happens at weaning. So it's a new model for ribeye, and that's why we see more change. Carcass weight EPD, this is one that we see because we changed the model, and we're going to see some differences. And an animal here that stuck out for me right away when I was looking at this graph was this one right here. Now here's an animal that was about 9 on carcass weight, and he jumps to 42. And we said, well, what's going on there? That's a big change. We dig into that animal a little bit more, and he has 126 yearling weight EPD, and that puts him basically at the top 1% of the breed for growth. So we did have in our evaluation, here's an animal that's top 1% for size and growth, but he was right at the bottom of the top 200 sires, one of the lowest EPDs for carcass weight. And now that's actually coming up, and he's kind of more middle of the road now for carcass weight. And I think that that makes more sense, where we have more of a relationship. Obviously, you don't want a relationship isn't one-to-one. Yearling weight does not equal carcass weight, but there is a positive relationship there, and this new evaluation is better accounting for that relationship, and that's why we see some more change in carcass weights. Dry matter intake is another trait that we've seen more change in. We've got more range now in dry matter intake. There's more spread. Dry matter intake is part of the $B model now, so this will influence animals' $B. But if we look at here, for example, here's, take this bull right about here. He was about a 0.6 on dry matter intake EPD, and he's going to go up over 1. So that's, again, a significant increase. Again, the trend is the same. The lows are still the lows and the highs are still the highs. And we have, digging now into our indexes, specifically $B and $W. So $B, beef in Angus is basically, it's a terminal index. It's basically profitability post-weaning for an animal right through to carcass. And there's 2 changes here now. We've actually got obviously the new evaluation. We got new EPDs in all the animals, but we've also got new economic assumptions, updated economic assumptions in our $B model, and that's something that happens at this time of the year anyways. And so those 2 things combined are contributing to changes here in $B. So let's say here's an animal that was $125 in $B. He's going to be about $90. So he's gone down. Here's an animal that was 145 on $B. He goes to 165. So he's gone up. Again, the low animals, these animals here that are under $75 are still under 75, and these ones here that were up 185 are still 185 on $B. But there is movement here in animals. And again, some animals kind of jump out at you. And here is one. He was south of $85 in $B, and he's up now close to 145. What's the story with this animal? And we dig into him a little more, and ironically, it was the same animal that I looked at before. That's the animal that went up so much on carcass weight. He was $80 in $B, and he went to 143. He's a high growth animal. It dragged up his carcass weight, and that's improved his $B quite a bit. It didn't send him up to $200. It brought him up more towards the middle of the pack. But his other EPDs have changed as well. He's dropped a little bit on marbling, dropped a little bit on ribeye. But again, we have to be careful to look at the new percentiles to see where he actually ranks in the population. And again, more spread in dry matter intake. He's actually gone up about 3 points. about 3 points on dry matter intake. But considering those things, he still went up on $B. Our trends in $B are similar, so the mean $B in recent years for animals is going to be pretty similar. Same for weaning weight, dollar weaning, which is profitability through to weaning. So we think, as we talk to breeders coming up to 7.7, I think breeders are excited. They, in their minds, I think they have this scenario that we've had this old pickup truck that they've been driving, and we've had this new one in the garage since November, and we haven't let them have the keys to it. And on 7.7, they're excited to basically get on the website and give those new numbers a test drive. I don't think this comparison is very fair, because I think what we've seen, for example, with the correlation with the BNM Research Center, from a lot of traits, the increase in accuracy is not huge. It's an improvement, and it's definitely better, but it's not that we've had really outdated technology. Breeders have had a good evaluation, and now we've actually made it better. So just to emphasize to people that there will be re-ranking, like we saw with those individual bulls. There are differences people will notice. It'll influence the value of animals. It's not minuscule, but we're confident it's better due to the testing that we've done. And it's better not just because of the method. The method is single step, and it's great to have that released. But the parameters are better. We know they're more reflective of the current Angus data, because we've re-estimated all those for all the heritabilities and correlations. The models for carcass, birth and growth have been changed, and they're more complete and accurate. And finally, a lot more data. So our current calibration is based on 100,000. Now we've got over 300,000 genotyped. And every week as genotypes come in, all that data gets incorporated in that evaluation every week. So there's no more lag anymore between people genotyping their animals and then those genotypes making their way into the calibration. Basically there's a new calibration now every time we do a run, every week. So we're excited about getting this released to our breeders, and I'd be happy to take any questions. Okay, I've got you back live again.